Number 34, integral from 1 to e sine of ln x dx. So this integral is actually not one that's super nice to evaluate. It looks kind of innocent, but it's not nice. Not that bad, but you'll see why if you never saw this before. Okay. Or if you got stuck, you'll see why that I'm saying that. Okay. So it's a composite function, first of all. So maybe I want to make a substitution to make it more familiar, the integram more familiar. Yeah, just so that it looks like something that we know how to tackle. Right now, I don't know how to tackle this. So let's try it out. Let's let t be ln x. So I can differentiate from there, but remember, I can also uh, exponentiate both sides first, or you can differentiate whenever you want. So I just exponentiated both sides first. So e to the t is equal to x. And then I differentiated from here. E to the t dt is dx, okay? So that it's a definite integral, so don't forget to change the limits of integration, okay? So it becomes 0 to 1. And then let's substitute sine of t, and then dx is e to the t dt. Now this looks very familiar, and hopefully now you see why I said that this is not a nice integral to evaluate, because this is integration by parts. And to show you work for this, it's not that nice. Okay? So we choose u to be either one, doesn't matter. Sine t, du is cosine t dt, dv is e to t dt, v is e to t then, okay? So we go through the motions of integration by parts, uv minus integral v du. So I'm not going to evaluate this first piece right away because I usually do everything at the end. And I know what to expect for this already because I've seen these before. Hopefully you went over something like this in lecture. Okay, so this you got to do integration by parts once again. So I chose u to be cosine t and dv is e to t dt, okay? So then we get this over here. Again, uv minus integral v du. Okay, so I distribute that minus sign to both these guys. All right, remember this is I. So I can move the I to this side, so it becomes 2i and then divided by 2. So I is this guy over 2. So now I evaluate from 0 to 1, and this is my final answer right here. Okay? This is a definite integral, so there should be no question that this is exactly the final answer. Okay, so once again, the trick was, at least for me, and how I approached it, is a composite function. So let's make a substitution to make it look a little different, and then this became familiar territory from there.